Rahim. Welcome back, everyone. Today's topic will be related to designing the REST API using a sample case study. Today's lecture and upcoming next lecture will be super easy and very important for all of you, specifically for the students who could not pace up throughout and want to get back to the track. So these lectures will be very important for those. So here is a golden opportunity to go ahead. So let's start today's lecture. First, we will quick recall from the last lecture what we have studied. In last lecture, we have seen some basic five principles of REST architecture. The first principle was the key abstraction of information in the form of resources and naming them into a URIs. Then the second thing, the representation of that resources in the sequence of bytes, like in which format we will represent that information and in which language we will represent that information. Third principle was related to performing on a small set of well-defined methods on our resources. We define the prescribed methods for each resource, that these methods will only be applicable. In this way, we will define a specific set of methods so that user cannot inject some information which is not required to be entered into our database systems. Then we will define the idempotent methods. Idempotent methods I have cleared in my last lecture, that those methods in which we perform a task one time or 10 time may not have any difference. So we will define those methods, and according to that method we will implement our REST API. And last, fifth, our all interaction in the REST API will be context free. That means the statelessness. My server will be stateless. These are the five principles on which we define our REST API. So what are the steps that needs to be done to create a REST API? First thing, we will figure out a dataset. We will define that datasets into different modules, and module will be divided into resources which we will provide. Each module will contain the resources that will be provided to the end user or some client. Third thing, we will define the URIs for those resources. Fourth thing, we will define the allowable methods for those URIs. Means if slash employees, so slash employees can be called with the get method or a post method, whatever it is, we will define that. The fifth step will be the representation of our data. Either we will provide the JSONs, we will provide the HTML, or we will provide XML. Then the sixth step will be defining the language in which we will provide the data. Seventh step, we will define the sunny day scenario for each route. Each route means each URI plus the method, and we will define the rainy day scenario for that route also. Ninth is the identification of security steps that needs to be implemented to complete our REST API to avoid any unforeseen circumstances. So we normally define the security step that will require to access our REST API. The last point, we will define the mechanism to make our server stateless. So these are the points, 10 steps that needs to be catered to, to follow all the five principles of REST API, and to define and to create our REST API, our own REST API. So we will take the example and we will follow these all steps one by one from step 1 to step 10, and we will see how this REST API can be built, can be designed. In this lecture, we will be specifically designing our REST API instead of implementation. In next lecture, what we will do, we will implement that REST API. So let's start. Let's take a case study of learning management system as basic learning management system. What it contains: an LMS where teacher can upload assignments, quizzes, lecture, helping materials, marks, and student can respond to quizzes, assignments, and view and download lecture materials and view results. So same admin can add classes, assign teachers, teachers, assign teacher classes, means assign a teacher to a class and add students into that class, add new teachers into the system, and can announce anything. Head can view progress of class or individual students and see any specific lecture materials. So this is a system description that needs to be implemented. So there will be a front end, a view end, which will not be covered in our REST API. View end will be covered using React or Angular, while our back end, that is basically the REST API, will be implemented here. So what will be our first step? First step will be to identify our set of basically routers or our modules. So first step, identify modules for REST. We have two options to implement this thing. First way is based on actors, like as we defined in our study, case study, that admin, student, teacher, and head are the actors. We define every functionality according to those actors. So this is one way. We can say admin module, student module, teacher module, and head module. Similarly, what we can do, the second option is, we can define all those functionalities on the basis of similarities, like quiz management, result management, assignment management, user management, class management, and reporting. So these are two type of defining the modules. It's up to us. Basically both way out have a plus and minus in it. Like if we ponder some points about option one, if we go with the role wise routers, then we can see, we can apply security and access permissions at the router level. Like an admin module, we will apply that the only admin can access the admin module. Same, a teacher can access the teacher modules. We can set a a student can access a student module. So all functionalities are accessible on the base of that role. So this is the plus point for this option. But what is the problem is the redundancy of routes. For example, a teacher can view uh, marks, a student can view marks, an admin can view marks, a head can view marks. In this case, view marks will be replicated in the four of routers. So you have to copy paste four times that route into different routers. So redundancy of route is there, and that is duplication. This is basically a negative point, but plus point is you have to implement the security at top level only. Then the option 2. In option 2, if we go with the set of relevant functionalities, it will minimize rewriting the code in each router. So like I will write view results, and then I will define the view results in a results management router. And the second step, the issue is, we have to define the access of every role for that route. Either security will be defined at a role level, so sorry, at route level, on route level, not on the router level, but on a route level. So we have to define the security at a route level, like slash view results can be viewed by admin, by user, our student, and our teacher. So definition of security will be on route level, not on the router level. So at the end, choice is yours. You can select any way to define your routers. Let's do it with role wise. We will start with this REST API designing with role wise. Like we will define the routers on the basis of our main characters or main users. So what we need to define the routers in our application, we need to define index router, we need to define users router, we need to define admin, student, teacher, and heads. I will explain what is a user router, and I will explain every router here. So let's start. These are our 6 routers that needs to be created in our REST application. This was our first step. The second step is to define the resources. For example, index router will display index page. index means the first information page, a first data set that needs to be sent to the user, and an error data set that needs to be sent end user. So index will contain only these two routes. Our user router will contain a route for a logging request, for a logout request, and a validation request. Login is so simple. Whenever user sends a username and password, it will be verified in our login router. Whenever user want to log out of the system, he will send a logout request. And whenever a subsequent request after the login request will come, we will validate the request. Either the session information or the token information is there. So this route will be there in the user router. So this module will provide the authentication mechanism and authorization mechanism for our REST API. Then we have admin router. Admin router will contain show dashboard, view class list, add new class, add new teacher, add new student, assign teacher to class, add student to class, modify class, delete teacher, delete students. These are the all resources that needs to be provided to admin router, admin user. Same student router, we will provide view quiz, attempt quiz, view assignment, submit assignment, view material, either it is a lecture material or some other material, and that material can be downloaded. Then he can see a grade in a specific subject. He can see subject or assignment. He can see his dashboard, and he or she can see the complete result of a complete subject or a complete semester. So these are the routes which needs to be implemented. Sorry, these are the resources, not the route at the moment, because for the route we have to define the methods also. For a teacher router, we need to provide the dashboard to the teacher. We need to provide him with the add quiz option, view attempted quiz, download attempted quizzes, add assignments, view submitted assignments, download submitted assignments, add material, view material, delete material. We are here, you can see we are not providing to update any material, but he can delete some material and can add some material and view that material. Same, he can add marks, delete marks, and update marks. Marks can be updated, but not the material. That is our design decision. Same, he can delete the quiz and delete the assignment. So these are the resources that need to be provided to teacher. Then the head router. Head is the head of the department. He can view the classes, he can view the results, he can view the individual results, he can view the materials that have been uploaded to the portal, and he has a dashboard and he can see some graphs. So these are the resources that need to be provided to head of the department. So we have defined second step. In that step, we have identified all the resources that needs to be provided to our end users. In the third step, what we will do, we will define the URIs and methods to access that router. In this case, like index router, the mount point for that router will be slash. After the request of localhost colon 3000 slash, this router will be mounted, and on that slash, what we will display an index information for that page, and slash error, we will display the error information. So this will be our index router. Then we have a user router. In user router, we will mount it slash on the base of slash user. Slash user is the base point from where this router will be called. And against that route slash user, we have slash login, slash logout, slash validate. For the login request, the end user will send the username and password. So he will use the post method to send these information to our router. We will pass that information and will provide the authentication mechanism here. Same for the logging out, he will just send a get method to log out, and we will destroy the relevant session. And for all other methods, whenever he will call, we will validate that request. Either he has a token or session information into our system. If that is there, we will provide that access to relevant router. If there is not so information in our system, we will forward him, we will request him to revalidate himself or send the credentials to login router. So this will be our user router. Then the admin router. If we want to add a new teacher, it will be a post request with the teacher's parameter, teacher's details. So he will call /add teachers. The mount point for admin router will be /admin. Against the /admin, this router will be mounted like localhost :3000 /admin /add teacher. It will receive the parameters from our end application to add teacher into our system. Same, add students, it will also be a post request. Add classes, it will also be a post request. Show dashboard is simple a get request. It is getting the information from the system. View class list, he can see all the classes. This is a get request. Modify class, for the modify class he will call a put method with a class id. Against this class id, the new information will be modified as per his request. Same, assign teacher out will contain the id of the teacher for which the assignment is required, and that assignment will be put operation. Same, the add student is will be using the put method there to update the information into the db. Delete, we need a class. To delete a class, we need delete method and a class and the id of that class. On the basis of that id, we will access the parameters request.params.id to delete that class. Same, we can delete the teacher, we can delete the system. This will be our admin router. Student router. Student router will be mounted at /student and localhost :3000 /student/ for the slash he will get the dashboard, /view quiz he will get the quiz. He can see the quiz and attempt that quiz. Then for against uh, view assignment, he can view assignment, he can post assignment, he can view material, he can specifically download specific material, he can view the mark grades according to his subject id, and he can see the marks completely. So these are all the basically uris and the methods required to implement that uri. Same, the teacher router that will be mounted against /teachers. It will contain this dashboard, then the view quiz, add quiz. On the same pattern, he can add the quiz using the post request. He can get information from the system by specific quiz id. He can download all the attempted quizzes against that quiz, and he can delete a specific quiz by giving its quiz id. He can view attempted assignments, he can add assignments, he can download attempted assignments, he can delete assignments, he can add material, he can view material, he can delete material uh, by delete methods, he can add marks using the post, he can update marks using the put, he can delete the marks using delete method. So we have defined what we have defined till now. We have defined our routers, we have defined the resources that need to be provided, we have defined the uris for every resource, we have defined our basically all the methods that needs to be implemented for this rest api till this point. So we have defined 4 points. He can for the header router, same, we can provide the dashboards, we can provide him the class view, we can provide him the results of a specific class with the class id, we can provide the results of a student with the student id, we can provide the list of material that he can see, and we can also add another route here with specific course id to see the material. He can see some graphs based on some specific criteria. So these are our four first point. Now, fifth point is defining about basically the response type. So we will send our resources at JSON object only. We will not provide any sort of view from our REST API. This is our design decision. So we have decided to provide all information in only JSON format. We will not provide HTML. We will not provide XML. We will not provide any text, other type of text. So we will provide the end user the response with the JSON data. Even we will send the error and not found pages only in shape of status codes. The HTML part is status code and the error message. We will provide the status code and the error message in case of error to the end user, and the view for that specific error or not found will be displayed by the end user application. For example, it is built in a React, so React will construct a view for 404 for any error, 500 error or any other error. We will not implement that views here in our REST API. We will only provide the JSON data. And the sixth point is defining the language. We will provide all the data into English language. No other language will be supported. Like a request in the French language, we can't process the information into a French language or any other Chinese language. So we will only get the information in English language and provide provide the response into English language. So these are the fifth and sixth points for our REST API. Seventh and eighth point: sunny day scenarios and rainy day scenarios. I'm taking an example of slash add teacher by the admin. Now, admin wants to add a new teacher into our system. For this, he will send some details of the teacher to the system. The system will receive the details of the teacher, add into our mongoose model, and that model will be saved. This is our sunny day scenario, and we will respond with OK message, 200 message. For the rainy day scenario, what can go wrong? First thing, the information sent on a specific route is not sent by a person who is currently logged in. Means he is not logged in. So in this case, we will send the message back that you are not logged in to send this information to our system. Second way out, he may be logged in but not an admin. He can be a student who is trying to send that information into our system. So in this case, you will check the authorization of that student in our user router, as I have validate route there. So the authorization, we will check the authorization. If he is not authorized, we will send him the response message, you are not authorized. The third thing, it can be possible the information sent to the system is already added into our system. So to make the teacher unique, we can respond back, teacher already exists. This is the third scenario, rainy day scenario, that can be different from our straightforward course of action. The fourth thing that can be, our database server is down. In this case, that is basically internal server error, 500 series error. So we can provide the response as a database could not be connected at the moment. So this can be a rainy day scenario. There can be another type of error. So that error can be a schema error, like the information sent to this teacher model is not compatible with our model. So in that case, this can be a schema error, like our required information is not provided by the system, by the front end application. So in that case, a schema error can occur. In this case, we will adhere to that schema element, and we will provide this error type to our front end application. So these are all the rainy day scenarios for a single route of slash add teachers for admin router. So we need to define these all scenarios so that we can handle these scenarios. These are all callback hells. We will this concept is called callback hell. Like you will check one thing, then in the callback of that thing, we will check another thing, and in the callback of this, we will see next, and on the this, and we have 5 stage callback, that is called callback hell. We can use promises also. The promises are dot, then we will see it in our coding that how can we use promises, or we can use callback hell to implement this thing. So these are our sunny day scenarios, and these are our rainy day scenarios. Now what you need to do, now please select at least one router that has been defined previously, and provide sunny day and rainy day scenarios for each router in that router. Just take a paper and just go through for each route and see what could be the sunny day scenarios and what could be the rainy day scenarios. In this case, you will handle all type of exceptions of your system. So this will help you to implement your REST API. So do it before the next lecture. It will help you to understand and implement your routers and routes in next lecture. Step 9 of our REST API, that is related to security issues and design decisions. In this step, what we have to decide, we will decide about its security. Either we will provide one thing is the authentication system, and second, cores and XSS, cross-site scripts. The first thing, authentication. We will define the basic authentication. Either we will use the basic authentication mechanism, that is username and password. We will define basically location based or third party authentication using the passport. Like we passport can also provide authentication based on some locations, and can provide a local strategy also. Same, we can authenticate with the third party softwares, just like Facebook, Twitter logins, and Gmail logins. We can use those using the passport. And we can also use sessions to manage the information, and JWTs to manage the information. So we will define these. First of all, after one lecture, we will go through these concepts. After going through these concepts, we will implement those on our this sample REST API. So these are our design decision. Whatever the strategy we want to implement, we can implement any of these strategies. Then the course issue, that is cross origin request. Either we will be allowing that cross origin request, or we will not allowing, or we will be allowing a specific IP address, or we will be allowing any request from any source. So this is our design decision. We will see in implementation part. And then the DDoS handling and crosses scripts handling, that will be implemented in our security issues. But this will be after one lecture. We will define all these concepts. We will go through all these concepts. We will implement these concepts, and then we will decide what will be the best policy for our system. So these are the this will be our ninth step. The last step is statelessness. Statelessness is basically related to our server-side storage systems. Either we have two way out to store the information of a client, or a user. One is on the server side, how we will store the information on server side, or how we will store the information on client side. On the server side, we can store the information. By default, it is stored into a server RAM. Any session or token information is stored into a server RAM, but storing any information on a server storage will alternatively make it stateful. We don't want to be a stateful server. We want a stateless service. So to do it, what we will do, we will use a specialized storage just like Redis, or we will use the MongoDB, or we can use the files on the server side end. We can store the sessions or tokens into MongoDB. We can store the sessions or tokens into files, or we can store the sessions and into our Redis server. So these are the three in way out with which we can achieve the statelessness on the server. On the client side, the sessions or tokens can be stored in case of cookies or into a local storage. We will see it after a few lectures how we can store the information into different storage spaces. So these will be the 10 steps that needs to be implemented to create our REST API. So what we have achieved today, we have designed our REST API in a way that can be implemented into a practical REST server. So what we will do, we will implement this case study which we have studied, which we have seen in from scratch. What we will do, we will create a first app using Express, and then in that app we will create routes as defined in previous slides. Then we will create the routes, or sorry, we will create the routers and we will create the routes. And then we will implement, I will implement at least one router. Here I is important because I will implement only one router. Remaining routers will be implemented by you as in your assignment. So be prepared for your assignment. I will implement any of this these one router. It can be head, it can be student, it can be teacher, or it can be admin. So I will implement one router incomplete. Remaining routers will be implemented by you as in your assignment. So inshallah meet you in next lecture where we will be implementing these concepts. Thank you very much.